Hi again, Linda.
Hi, Barbara.
So, decimals.
Decimals. Well, if we did
Decimal fractions, right?
Yeah. Well, actually, that was the original name.
Decimal fractions?
Yes, that's what they were called originally when
Yes.
they were invented.
But don't some people still call them decimal fractions?
It could be.
Yeah, and the decimal point is, this is, there's neat clarity around all of that stuff. So, this is what I want to talk about today. You know what is remarkable about our numbers that people absolutely take for granted is that we can write any numbers with just 10 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
Right.
We can write any number.
Doesn't matter how large or how small.
We can write any number. And this wasn't always true.
That's true.
Yeah, and in fact, and I'm gonna. There's a spot on the web where you can deal with this. The number 276.
276.
You can look this up on the web.
276.
If you were using Egyptian hieroglyphics, which was a way of writing numbers, you would need 15 symbols to write that.
Wow.
And you can look it up on the web. It's very cool.
15 symbols?
Yeah, to write that.
Different symbols?
Yes. 15 different, you'd have to write down 15 different things.
Yeah.
And here's how you'd write it in Roman numerals. M.
M.
Yeah. M.
N.
M.
M. Another
Yeah.
M.
Yeah, that's 2 of the hundreds. Those things they call hundreds.
Hundreds. So we have 2 hundreds and now we need... Do they actually do 70?
Wait, are those 200s?
I thought those were thousands.
Those are thousands.
Oh, I'm writing a different number.
Hundreds are C.
Uh-huh. So that's 2,000. Oh. Cross that out.
Which one?
Both of those M's.
Okay.
Get rid of that stuff.
So now we're back to, I just wrote 276 and the Egyptians have already gone.
Yeah.
And now you're going to start guess what the Romans.
Yeah. The Romans would have written C.
C.
Yeah.
Equal.
C. C.
Another C.
L.
L.
That's 50.
50.
X.
That's a 10. I remember that.
Yeah. X.
So there's your 200s and 50 and 2 more, 2 10s is 70.
And V.
Must be 5.
And I.
I.
So that's how the Romans would have written it. Right. But we just write it with 3 different symbols.
So if I wanted to add millions or 10 millions or 100 millions,
Yeah, or thousands.
I would have to come up with a new symbol.
Yeah.
Okay.
But we're very lucky.
Yeah.
And we take it for granted. So let's look at how this all works out.
Okay.
And it's about our base 10 number system.
Under here or over?
No, let's do it. We could do it. So let's write another number. Let's write the number 3,274.
Write it here.
Yeah.
Big
why don't we write
as
here?
digits.
3,274.
Okay.
Okay. So it's an interesting thing that I read in Math Matters, that book by, who was it? Who were the authors? Johnson and, I can't remember the other person's name. On the face value of this is 3. The place value is 1,000.
So
3,000.
okay.
The
2 hundreds, 7,
10,
70. Okay.
and 4.
Huh. Face value.
Yeah, face value is this. It's just, it's an interesting term. So, but we promised, well, look, here's something. 1, 10, 100, 1,000, 10,000. every time you go in this direction,
We multiplied the prior one by 10.
yeah, that's right, right? And so the next one would be,
100,000.
and we could keep on going. We
Yes.
just have to multiply by 10 and we get the next one, which is very, very convenient. Now here's what's even more convenient. If we put a decimal point right here, let's put a big decimal point.
Okay.
And let's put a big decimal point over here too. That's the, now we can get smaller.
So here I'm multiplying by 10, but if I want to get smaller, I have to go back. To get from this number to this number, I would have to divide by 10.
Yeah,
The inverse.
yeah,
And divide by 10.
from, yeah,
And
100
10 divided by 10 is 1.
1, and 1 divided by 10
is 1/10.
yes, 1 into 10 equal pieces. One of the 10
Oh.
equal pieces, so this is 1/10.
So it is 1/10.
Yeah. 1/10.
Do I put a decimal there?
No, we need
Decimal.
1/10. 1/10 fraction.
Yeah, I do. Well, I just realized that. 10.
Yeah.
1/10.
Yeah. And so this one is divide a tenth into 10 equal parts.
Would be 1 out of 100.
Yeah.
1 out of 100.
Yeah.
And then this one would be 1 out of 1,000.
1,000 equal pieces, yeah. And again, we could keep on going forever and ever in this direction too.
Yeah.
Okay. So if we write a number in here, you could write any number, any digit. Yeah, yeah. So this number now is 3,274, and that's the only place you're ever allowed to say "and" in when you're
Math.
reading numbers. 8 tenths and 6 hundredths and, well, I guess we could keep on saying "and" 5 1,000ths. Yeah. Now this is a very interesting.
But
thing
you
here.
don't read this as
Yeah, and this is a very hard part, and this really, we're leaving out a lot of steps in here when we say this is 865 1,000ths. We're leaving out a lot of steps, and we need to know that. We're just saying it here, but kids would have to go through a lot of things before they could get to that.
if you don't think about this 5 thousandths, this is 86.
Like 86 cents,
86 cents.
which
Right.
is like 86 out
Which
of
is
100.
8 tens and 6 pennies. 8 dimes and 6 pennies.
Yeah.
So
a dime
it-
is a tenth of a dollar.
Yeah. So even though we say 86 hundredths, we call it hundredths because that's the largest division, I guess.
Yeah, 86 hundredths. Yeah. And this is confusing.
Yes, it is.
It's very confusing.
It's like that business about the larger the number, the smaller the fraction
Yeah.
in the denominator.
But it's also confusing because 86 hundredths and 865 thousandths. Yeah. It's
Confusing.
It can be very confusing.
All right.
Okay. So, what we're going to do is play another game.
Ah.
And it's another in-between game.
Okay.
So we're going to, and this time we're going to have the in-betweens are 0, a half,
And 1.